also the importance of having access to foods without these type of amine compounds or low compositions. So we can see here in this presentation, in this article, that certain levels of toxic biogenic amines in fermented food could be of concern. And histamine that can be found in foodstuffs. Histamine is therefore the one that is actually the greatest threat for health, because it is the one that leads to histamine toxic syndrome or toxic poisoning. This is something that has been known for a long time. It was identified for the first time in 1955 after having eaten tuna in an unhealthy condition. So this has been associated to eating food, mainly tuna and their other fishes of the same family, herrings. The WHO has recommended that we talk about intoxication, histaminic intoxication, poisoning, because this can be the result of eating these species of fish, but also it can come from other food stuffs. So this takes place when the level of histamine is very high, and therefore the degradation is very high, and we can see typical symptoms like on the skin, redness, pruritus, inflammation, also nausea, diarrhea, hypertension, headache, sometimes also different experiences. Also, we see this kind of food poisoning where you can even feel tingling, but in general, the symptoms are not very serious, from low to mild symptoms. They can appear at about 30 minutes after ingestion, and remission takes place within 24 to 48 hours, mild to moderate symptoms. So here we can see the incidence in different countries of the European Union. And in orange, this food poisoning or intoxication is a problem in terms of food safety. Here we have in other colors other types of intoxications, and we can see that since 2010 the number of outbreaks has been growing. If we compare this to other food intoxications, we see a different trend. Listeria, for example, as you can see in purple, is quite lower in terms of number of outbreaks. The most recent data that we have from the European Center for the Prevention and Control of Diseases, we can see that in 2020 there were 43 outbreaks affecting over 183 individuals. About 9% of them had to be kept in hospital, and there was one death caused by histamine intoxication. In 2020, we see that the number of outbreaks was reduced in compared to previous years. In 2019, there were 96 outbreaks with 428 affected individuals. And we see that in, for example, 2016, there were over 90 cases in Europe. There was a suspension of restaurants and canteens at schools and job workplaces. And this is why also there was a reduction of the intoxications that, as you can see, this was related also to the pandemic because all those places were closed. So as I mentioned, there are different cases of intoxication, and sometimes we see this on the papers. You can see here some examples where we don't really refer to histamine as the cause. Here we do see a reference to histamine in relation to the foodstuff, but in most cases we don't really refer to histamine on the press, but just to the foodstuff, so tuna. So it is well known that histamine intoxication is a risk, but most, in general, the population doesn't know this term. And although this intoxication has been very much studied during the last few decades, there are still some pending questions. For example, the fact that there is no consensus relating to the quantity of histamine that is responsible for those outbreaks. We found histamine levels that can go from 200 milligrams per kilogram in foodstuffs to 8,000. So very variable figures. That is according to the review by Colombo et al., covering nearly 50 years here. Inter-individual differences in histamine tolerance. So the population that has a greater sensitivity to histamine, linked probably to the DAO deficiency, could be the reason why these figures are so variable. And the fact that there are different clinical responses to histamine, even within the same outbreak. So the problem there is not in the foodstuff itself, but in the human body, in the individual. So this DAO deficiency, this higher sensitivity to histamine, is known as histamine intolerance caused by DAO deficiency. And this means that there is a lack of capacity to degrade histamine, and this leads to the different symptoms and its accumulation in the body. So this is what we can see here, how, well, this is something that we've already seen this morning, this graph. So we have, this is a normal condition where we can degrade histamine. This is a healthy person. This would be a situation of histamine poisoning, where you see in green the DAO enzyme, which is active and functioning, but in the case of an acute intoxication, the quantity of histamine is over the normal capacity to metabolize it, and therefore there's an excess level in the body. But here we have a case of histamine intolerance, where we see normal levels of histamine, the same that we can see in a healthy individual, but there is a deficiency in the DAO enzyme, and that is partially or completely inactive. And then we see the same situation as in the histamine poisoning situation, where we see symptoms that are similar. So the problem is that we've got histamine in the body for whatever cause. We've seen that the fact that different quantities of histamine can have different impacts, and that could be due to the presence of of alcohol, for example, or other diamines. So in this case, the combination of these compounds could empower the intoxication of the histamine, because the degradation of histamine would be even reduced because they're using the same metabolic paths. So we've been able to show in vitro that the presence of prutosine and cadaverine, these two enzymes I referred to earlier, would reduce the degradation rate of histamine. And this is what we try to show in these graphs, where we can see first the kinetics of degradation of histamine by the DAO enzyme in green when it is alone in the medium, but there in the other colors you have the presence of putrescine, cadaverine, or the combination of the two. So we can see that the enzyme has been able to degrade histamine completely in the case of green, but when we see that when there are other enzymes, for example, putrescine and cadaverine present, then more time is required for the complete degradation. And here we have the proportion 1:4. In this other situation, we have amines with higher concentrations, up to 20 times more. Here we can see the impact in the degradation of histamine. 90 minutes, after 90 minutes, when histamine is alone, and then we see here that with the presence of those other amines, only about 20% of the histamine has been degraded at that same point in time. So that could be the reason why we see this increased impact of the histamine presence in the human body. So both in intoxication and in intolerance, histamine in food is the cause of these impacts on health, and this is why we need to know where it is coming from. Histamine in food is composed or caused, well, we've talked about the human being earlier, but now I'm talking about the food. But in the food is because of what happens with the action of bacteria, gram-negative and gram-positive bacteria. And in the case of gram-negative, they need a cofactor, pyridoxal 5-phosphate, and in gram-positive, it is an enzyme that is pyruvoyl dependent. So there's histamine in foods, but also we often find other types of biogenic amines like tyramine, putrescine, and cadaverine. And just as in the case of histamine, they are formed in the same way. All these amines, well, the foods where these amines can be accumulated in high concentrations are the ones that have suffered bacterial contamination, like meats and fish and the derivated products, and those that have been kept in bad conditions. It is important to remember that amines, not only histamine, but all of them are thermal resistant, and this means that although thermal treatments that are applied in order to obtain the subproducts, bacteria are therefore eliminated, but amines do stay in the foods. So they cannot be eliminated. Also, in fermented foods, bacteria that are responsible for the fermentation can have the capacity to do the decarboxylation. In some cases, we have them in a natural condition, like products containing blood and some vegetable products too. From the regulatory point of view, there's only regulation, some threshold values in the European Union and also in the US, prepared by FDA, and also in some other countries, and they only exist concerning histamine and only in fish and fisher products. That's the only regulation that exists right now. Nevertheless, as we can see here in this graph, Here we have foods in the Spanish market, but there are many others. Here we have fresh fish, for example, and also other fish products, but we see that there are many other products that may contain high histamine concentrations like cheese, fermented soybean products, or dry fermented sausages with levels that, as we can see here, are even higher than the ones we find in fresh fish and canned and semi-preserved fish, the only products for which regulation exists. So taking into account this framework and in this scenario, well, in order to reduce the cases of histamine intoxication and also in order to improve the quality of life of people with histamine intolerance, measures are necessary in order to reduce and eliminate the presence of histamine and other amines in these foods. First of all, we need to guarantee the hygienic quality of the materials, as I mentioned that contaminants may be the responsible for the creation of the amines. Well, we need to make sure that there are critical controls at specific moments of the supply chain. In the case of fermented products, where we can have a high concentration of amines, different methods have been studied in order to control and mitigate these type of compounds. For fermented products, we know that there's not one single measure that will be 100% functional, and instead we need a combination of all the different measures that are required. First of all, the hygienic quality of raw materials is key, as well as of manufacturing processes. In these studies here, we have some examples that show how important it is to use very raw materials with a very low bacterial load in the fermented products production. Here we have the cheese here in pasteurized milk in white. So with a reduction in the microbial load, no biogenic amines were generated in comparison to the same cheeses in gray that have been manufactured using raw milk. In the study here in the right, we can see this was also carried out by our research group, and here we have meat products used in fermented sausages. Here, no thermal processes may be used in order to reduce the bacterial load. And we saw then that a different measure is necessary using high pressure. And thanks to these measures, we could reduce, prutasine and cadaverine nearly to zero. Nevertheless, in orange, tyramine, which is very much associated to fermentative bacteria, even though we control the hygiene quality of the process and the raw materials, well, here we couldn't reduce that. So this is why I mentioned that different strategies are required in a combined way. For fermented products, we also need initiative cultures with bacteria that will not have the capacity of decarboxylating the products. So here we can see the efficacy of the use of different bacteria without the capacity of decarboxylating amines. And here we have the control group first. And then in these two cases, we had the reduction of the amine quantities, although in the case of L. curvatus, this amine could not be reduced, although in L-Sakei we did achieve a high level of efficacy. Here on the right, we can see a summary of different studies where initiative starter cultures have been used. And here we can see their efficacy in the reduction of amines. We can see that although in many cases the efficacy is high, here we have the percentages of reduction, but often we cannot reduce 100% of amines. In this sense, during the last few years, we have explored a new approach, a new mitigation approach in order to use production or formulation techniques that will reduce the amine accumulation in these products. And that would be thanks to the action of DAO enzymes. The DAO enzyme was identified for the first time in 1929 by Charles Best in lung tissue. It was called histaminase to begin with, but then later on it was, well, the name was modified to diamine oxidase because it degrades other matters too. We can find it in all sorts of animals and plants too. And we can see that it can go form the aldehyde and transform histamine and degrade histamine. This new approach can be used, and this is the one that we've been studying during the last few years in the use of starter cultures with the AO activity in order to degrade the amines that have been already formed in the fermented products. This new approach is in development. It has not been studied as much as other measures. The starter cultures that I mentioned earlier are already being implemented in the industry, in food companies. And the new approach with the DAO activity bacteria is something that is in development. Here we have a review by Alvarez and Moreno Arribas. We see that most studies are quite recent, and they are assessing the efficacy of all these strains in vitro, but also in the foodstuffs, in the food products. I would like to highlight the study carried out by Herreros Fresno et al., where they tested 300 different strains of cheese, and only 11 showed the capacity here to reduce histamine and tyramine with a capacity of greater than 25%. So a significant capacity to degrade these amines. So the authors found that this capacity is not very much distributed among the strains, fermentative strains. The ones that had a greater efficacy were tested on cheese, and 2 of them were able to produce cheese free of histamine, and in one of the strains, nevertheless, didn't achieve this goal. So additional studies are required. We, in our group, have already considered this DAO activity in different bacteria strains. And as in the previous study, we also verified that this DAO capacity is not well distributed among the different strains. We've assessed over 50 strains, and we have only found 17 with significant capacity to degrade histamine in vitro. We also found that the activity was very variable. It is dependent on the strain. Here we have the same species in the same color, but within the same species, we see that the capacity will be very different depending on the strain used. So in order to overcome all these limitations, we are now considering other approaches, and that would be the direct use of the DAO enzyme, so an enzymatic reduction instead of a biological reduction. We would be the one, the name we can use for using starter cultures with DAO activity. So the enzymatic reduction that would be achieved by adding the enzymes directly to the foods has not been studied. I would like to remind you that the kidney, pig kidney, is one of the main sources of DAO enzyme for using it as a model for biosensors and also for the treatment, dietary treatment of histamine intolerance. And since 2017, it has been authorized as a novel food, the pig kidney protein extract, to be able to use it in order to treat histamine intolerance. And as I mentioned earlier, the use of DAO enzymes directly in foods has not been studied, but we do find some examples like this paper where we added to fish. And here the main goal was not the capacity achieved by adding DAO in a direct way, but to analyze the degradation by starter microorganisms. And DAO was only used as a comparison element. But here we can see that we achieved 86% of degradation. So it was very effective and with pH levels that are closer to the fermentation levels. And these are extraordinary results, very interesting. In this other study in cheese, we see that the goal was the same, to analyze the use of starter cultures. But here it was compared to the use of directly of DAO enzyme from pigs. So here we can see that we have different types of cheeses. In the first one, the spontaneous cheese, and in the other cases, we culture starter was used with histamine, and here there was histamine, but nothing else. And in the other cases, so different microorganisms were used, all of them with the capacity to produce histamine. And in the last group is where the pig DAO enzyme was added. So it could reduce the level of histamine in similar efficacy levels than with other microorganisms. And in some cases, microorganisms achieved even lower levels. So additional surveys are necessary to understand the efficacy of adding DAO enzymes directly. Finally, in this paper that was published recently by Lucas Kettner and others, they have achieved a very high DAO activity. Here we can see that in vitro there's a histamine reduction level that is very interesting, with quantities that are the typical ones we find in foods. And here we see that it is got a high selectivity capacity, not only for histamine, but also for other amines that can be found very frequently in fermented products. Here in the paper, the authors conclude that this enzyme could be very interesting to be used in the food industry for the degradation of amines.
And finally, apart from these origin or recombination one in the last few years, they mentioned about the possibility of having this DAO enzyme derived from these products after the this would give an enzyme, a plant-based enzyme with an enzymatic activity, which is very similar to the other extract we mentioned before. And in this case, the plant-based DAO, and according to our knowledge, there are no studies that have assessed its capacity for degrading histamine in foods, but we think that its use in the formulation of these fermented products could be a new strategy of control, which would be based on histamine reduction and other amines. And to finish, and by way of conclusion, to tell you that one of the challenges of the food industry currently is to offer products with low levels of not only histamine but other amines to reduce the risk of intoxication, which is a high risk currently, but also to offer foods that are more appropriate for those individuals that are histamine intolerant. And for that, and to get that, what is important? Well, these three pillars are the ones that we should focus on. First, that there should be legal thresholds of histamine and for other foods, and why not for other amines? So we should make these wider, not only for fish, in the case of control measures. The industry should apply all those mitigation strategies to assure the good processes, the use of fermentative bacteria, not only non-aminogenic ones, but ones with DAO activity. And of course, as well, and although we do not have enough studies, the direct use of DAO enzyme as an ingredient or as a technological helper in the production of fermented foods. And to finish this last pillar, it would be also advisable, interesting, or important to have in the future the possibility of talking about the presence or the absence of these histamines on the labels of the products. And this would be very helpful for those who are histamine intolerant in order to have a more informed, perform a more informed selection of the foods they can take, and that would help them to improve their quality of life. This would be, as we were saying, a great challenge for the food industry. And I want to finish my presentation here saying thank you very much for your attention. And I would like to thank the whole of the research group for the results that we have been able to show you. Good afternoon.